Howdy folks, welcome back to another Out of Spec Renew video. For those who've been following the channel for a while, you may remember that back in June I picked up this 1998 Solectria Force. It's kind of been on the back burner as a project just because I've been too busy working on customers' cars and not my own stuff. But in this video we're finally going to be working on getting it running. It's been a long time since I first picked it up and originally started working on it, and then until recently when I restarted working on it, and I think some footage may have gotten lost in between the time span there. So hopefully the timeline of things isn't too confusing. And yeah, hope you guys enjoy. I suppose since it's been such a long time, I should kind of reintroduce this car, since not everybody who watches the channel now may have seen this when I first got it. But it may look like a late 90s Geo Metro, and that's because that's essentially what it is. Solectria actually bought these cars as gliders from GM, and with no powertrain, and then they put their own fully electric powertrain in it. It actually has a 3-phase AC motor under the hood, and was originally powered by 13 12-volt lead-acid batteries split between two separate battery boxes, one in the front under the hood, and then another much larger one in the trunk. This car previously had a lithium iron phosphate pack in it under prior ownership, and then it was actually parked for a substantial period of time before I got to it. And the batteries had since been removed. They'd gone bad. During its time sitting, it got caught in a major hailstorm, supposedly baseball-sized hail, which is why the windshield's cracked. The body's got lots of dents in it. I don't know how well those show up on camera, but we got lots of dents in the hood, the roof, the trunk, all over the place. These patched up holes are actually where the car once upon a time had a solar array attached to it. I don't remember if we may have tried to show that in a previous video, but I actually found pictures of this car online with the solar array on it. And yeah, so just kind of wanted to reintroduce the car for those who haven't seen it before. And now, I guess without further ado, let's go back in time when I first attempted to try and get this thing running again, and we'll see our forward progress on this project. So first, let's start under the hood here. There's a bunch of things that I kind of discovered here that I realized were a bunch of connectors that were disconnected, unplugged, or what have you. So to start off with, I did notice that there's a temperature sensor on the motor here that had two connectors on it. And there was another pigtail harness in here where both of the connectors were just connected together. I think that they bypassed the connector on the motor for the temperature sensor. There's no mention in the manuals whether or not there should be a temperature sensor on the motor, so maybe it's possible that that thing went bad. I actually reconnected it. If push comes to shove and we have an issue here, I can always disconnect that and bypass it if we have to. There's a couple of other things that I found, like a connector for the vacuum pump, and then there's some other sort of seemingly random connectors in here that I think are from the original Geo wiring when Solectria got these cars as gliders that would have been for a gas engine. So there's some connectors here that are part of the factory GM wiring harness. In addition, on the motor controller here, or the inverter, whatever you want to call it, I did notice that this connector is for our regen brake light control, and this end is actually not connected. There's another wire here on the motor controller that I thought might have been for that, but it turns out this is actually for the cooling fans, and this connects to another spot inside the controller. It does look like maybe someone's had this controller apart before, so fingers crossed there's not anything actually wrong with it. We do have to pull this controller out in order to get to the lower battery box here in the front. So I will go ahead and open up the access cover on the controller and reconnect this wiring the way that it's supposed to be. And then of course we have just our main high voltage cables for the battery pack, and we have our labeled service disconnect there. But yeah, in order to get this stuff out, we will have to or rather, in order to get the batteries in, we do have to remove the controller, and we have to move the AC compressor out of the way. This stuff is actually already unbolted. It's not actually being really held in by anything. Rather, this does have nuts on it, but they're loose. Then this is actually totally not bolted in at all. It's just sitting on top of the mounting studs in here. So we should be able to pull that out pretty easily. We'll just have to disconnect the 3 phase wires here, which are basically just right inside this outer sheath cover. We can unzip that. It's like sort of a protective cover and a grounding shield. And these are just basically Anderson connectors. So we can just pull on these and they will unplug. So that's those done. And then we also have our serial communication data low voltage cables for the motor controller itself. These are actually screwed together, so I'm going to have to go ahead and unscrew those in order to separate them. And yeah, that's pretty much it here up front. I'll go ahead and get all this stuff disconnected. We'll open up the controller, make sure there's no issues there. Let's go ahead and take a look at the battery situation. So if you tuned in for my first video where I introduced this car, I also showed at the end of the video that I had a C-Max energy pack that we're going to use to test the car and make sure that it's functional before I invest any money into any kind of real battery solution. These are 2 of the modules out of the C-Max pack. It normally has a total of 4 of these. Each module has 21 cells in series. So with both of these together, we'll have a total of 42 cells in series, which is going to be right in the voltage range where this should be happy. I believe that when it did have a lithium iron phosphate system in it previously, it was running on a lower voltage. So it's possible they may have programmed the motor controller to have lower voltage limits. So we'll see about that. I do have a serial adapter coming in for the motor controller in order to check the programming parameters and stuff on it, but I'm going to need to get an old school 32-bit laptop in order to run the program to connect to the controller. But anyway, we've got our 2 battery modules here. One is going to go in the front, in that front battery box that we were just looking at, and then the other one is going to go in the rear battery box in the trunk. I've added a couple of just basic little bus bar studs to stick up so that we can connect our cables to them, because the connections are a little bit too far recessed in here. So you can see I've got one here. This end actually has a factory cable on it that I'm just going to leave on, and then I added a couple of those 90-degree bus bar angles on this module as well. So that should all be good to go. I guess now we can start pulling the controller and stuff out, and then we'll take a peek inside that thing. All right, so first I'm going to go ahead and remove our AC compressor assembly. There's only one connector here, which is just for the motor itself. So we'll just unplug that. And then I've already loosened the bolt, or rather the nuts off of there, so we should be able to just pick this up. Kind of slide it out of the way here just a bit. And then we'll just lift it out of our way and set it off to the side here. That way it won't be in our way when we go to remove the lid on the battery box here. So now I can go ahead and remove the controller. I have disconnected both of the serial cables. Of course, we have our 3 phases disconnected, and then this would be our DC in. That's really all the connectors here, other than the one that normally would have been for the regen brake light control. And that's already unbolted as well, so we can just pick it up. And we'll go ahead and set this on the table where we can take a look inside. All right, so we've got our controller here on the bench. We can go ahead and open up this panel. A lot of these screws are kind of stripped, so hopefully it's not too much of a pain in the butt to get all these undone. But I will go ahead and pull all these out, and then we can remove our access panel here. All righty, all of our screws are out. Moment of truth. We can pull that off. Okay, so it looks like some of our positive DC cable here is loose. Our negative appears to be tight. And I think our 3 phases are all tight, although that seems a little loose on the inside. Hopefully that's not indicative of a problem. I don't know if that's just a little bit of flex. But I'm going to go ahead and pull up some pictures of where our wiring needs to go inside of here, which, looking at it, I might have to pull the rest of this cover open to get to the screws to actually attach those. I thought that I could do it from here, but I think the rest of this cover is going to have to be pulled off. So I'll go ahead and pull the rest of this off, which means I guess we'll have to disconnect all of our phases and stuff here. And hopefully we don't see any major damage inside of here. So yeah, I'll bring you guys back when I get the rest of the cover off here. I'll have to pull all the screws off and disconnect this stuff. All right, so I've got the cover pulled off here. I actually flipped this around backwards from the direction that we were looking at it before. But yeah, so we have the whole thing taken apart here. It's pretty clear to me that someone has had this apart before, just because a lot of the screws were stripped out or missing. And of course, you know, we have these wires that have been disconnected. I don't see anything visually wrong in here. I don't see any components that look like they've been smoked. So hopefully it wasn't opened up for any reason that would have been a problem with this thing. But obviously we've got to get our connectors back on for the cooling fans and for the regen brake light control. There were also a couple of loose fasteners for the positive power in, and then everything else here seems like it's fine. So the tricky part is I don't know how I'm going to get these reconnected and be able to get the case back on. So these wires go into some of the terminals on these blocks. I think I'll have to go back and look at some wiring diagrams, but I'm pretty sure that the fan control goes here, or maybe that's the regen brake light control. I don't remember, but I'm pretty sure that 2 of them go there, and then the other 2 go somewhere on this junction block. Don't remember where. But yeah, like I said, the tricky part is going to be figuring out how I'm actually going to get these in such a way that I can still get the cover on. I might have to disconnect the wiring from the fans on this end and then reconnect it after it gets put back together. Although even then, I'm not 100% certain that even that makes total sense. The regen brake light control, I think I'm going to have to do something similar, and probably, if I actually grab this and pull it out of that cable tie there, I might have to de-pin this connector and then connect that, feed it through the gland when we go to put the main cover back on. I guess you can't see my hand there, but when we go to put the main cover back on, I might have to feed this through the gland and then put the connector back on here after the fact, because I just don't see any other way to get this put together and feed those through the glands, unless I can get it started through there with enough slack maybe that I can put the cover next to it. I'll have to play around with it a little bit and see, but I need to pull up the pictures that I found of the wiring for this thing. By the way, a great resource for kind of some information, lots of pictures on repairs and access to the actual programs for doing the diagnostics and the special adapter for doing the programming itself, which actually lives right over here on this side. The guy that has all that stuff put together, their website is called Wolftronics, and they've been doing repairs on Solectria, Azure Dynamics, Brusa components for a long time. And yeah, they just have tons of great documentation, photos, diagnostic, and parameter setting programs, all that good stuff. But anyway, I'm going to go ahead and pull up the pictures of the wiring for this, figure out where we need to connect everything, and then we'll get that going, and then hopefully we can get this thing back together. All right, so I managed to get this all sorted. I did end up having to disconnect the fan wiring from the actual fans themselves. This was just kind of hot glued into the casing, so I'll be able to reconnect that, and yeah, we're all good there. If you can take a peek down there, so our brown wire is towards the outside edge, our white wire is here. These two for the brake light control are basically just a ground. There's a little relay in there that closes the circuit. It shouldn't matter the polarity, but both wires are the same color, so there's not really a way to tell which is which very easily, and there's not a wiring diagram that says one way or another. But it is just a relay that closes the ground essentially. So we should be fine there. Everything else is all tightened up here. I've just got to go ahead and screw the case back in, get the cover back on, and get our data connectors reconnected, and then we should be good to go. All right, we're fully assembled on our inverter here. So our next step is we're going to go ahead and get started on installing the batteries. So we'll do the first module is going to go in the front battery box. We'll get the rest of the stuff assembled up there, and then we'll put the one in the rear battery box. We'll do a little bit of a pre-charge. Since this car does not have a pre-charge circuit or contactors or anything, I will do a bit of a pre-charge just with a resistor so that we don't have a big current when we go to connect the batteries. So this has a bunch of capacitors and stuff, so I don't want big inrush current when we go to reconnect the batteries to it. So we'll start with the one in the front, get that all assembled, and then before we do the final connections on the rear battery, we'll go ahead and do a pre-charge, make the final connection, and fingers crossed, hopefully this thing will run. All right, I'm gonna go ahead and zip the cover off of our front battery box here. I haven't yet seen what's inside. Of course, I'm dropping fasteners now. But we should just have a couple of cables, and there will probably be a harness for a temperature sensor. But we won't be using that. That's for charging, and of course this doesn't have the original charger in it, so we won't need that. All right, so as you can see, I got the lid out of the front battery box here. What I ended up doing is I actually removed the DC to DC converter and laid it off to the side here, and I was able to flex the lid enough just to get it out of there. But now that I've taken it out, I've realized I didn't actually need to do that because they already bypassed the front battery box here. They just connected positive to negative here so that all of the batteries would go in the trunk, which, thinking back on it now, kind of makes sense since they had that lithium iron phosphate pack. So essentially the front of the car here is basically just dead space. So I'm going to go ahead and put the lid back on, and I guess we'll put both battery modules in the back rather than one in the front and one in the back like I was originally planning to do. So yeah, anyway, scratch this plan, on to plan B. All right, so I got everything under the hood here, all reassembled, plugged in. Everything is good to go. Now we can move around here to the back. We'll go ahead and get our modules mounted in the trunk here and connected up to our high voltage cables. I gotta clean out some of this junk first though. All right, I've got most of our rat's nest of wiring cleared out of the trunk here. Let's go ahead and get the modules in. I think I'm going to start with this one, because this can be our negative end of the pack on this side, which is going to connect to the cable down there that has the blue thing attached to it. This is a current sensor for their aftermarket battery management system they had in here. So we can go ahead and get that put into place. Is that going to work for me? I was hoping to use this cable to attach the two batteries together, but maybe I will have to flip this around the other way. So this is on the positive end of this module. If I move this over to the other side though, my positive cable, oh no, positive cable reaches that far. Okay, so I'll scoot this over to the other side. Like so. I guess it didn't matter too much that I thought we were going to be on opposite ends. So that still doesn't reach. I might have to add just a short length of cable to attach these two together. Only mildly sketchy. Let me go ahead and get my gloves on and we can start actually attaching cables to things. Alrighty, I've got tools, got fasteners, I've got my pre-charge resistor, and I've got gloves. So, oh, I forgot I need my short little cable length there. Let me grab one of those two real quick. All right, that ought to do the trick. So I'm going to start by getting this piece of cable started, although this has pretty big holes in the lugs. Let me see if I can find another cable option. Alrighty, I've just made up a new piece of cable real quick. Now we can go ahead and get this thing going. It's getting dark, so I don't know that I'm probably really going to try and drive this much if it does end up starting tonight, but I do still want to see if it's going to run. Okay, now before I connect the positive terminal, I want to use my pre-charge resistor so we don't get a big inrush current. Trying to think what the best way is going to be to do that. I might try and get a piece of wire, or mainly it's just for the capacitors in the traction inverter, because that's going to have a pretty big inrush current when we go to connect this. So if I just do a quick pre-charge and then, quickly after I take the resistor off, connect the positive terminal, we should be good. I mean, the service manual doesn't even recommend a pre-charging procedure to connect everything. It basically just says to expect a large spark when you go to connect it, which, yeah, I just want to prevent doing any kind of inrush current because that can damage components. So we'll go ahead and try and do a pre-charge here. I do need another bolt because I realized I'm short one. I'm going to get that de-staged over here, hopefully, along with my tools so that I can quickly get this connected. So go ahead and touch that on there. Okay, so we did get a spark for our pre-charge. Just hold it there for a couple seconds, and then I'll quickly go to connect this. All right, we're all tightened down. We should be good to go to reconnect the service connect under the hood. And let's see if this thing runs. All right, so here under the hood, we've got our service disconnect, which just connects these two little Anderson pins together. Okay, we got a bit of a spark, which that'll be for the DC to DC converter. And let's go ahead and see what happens if we try to hop in here. I don't see a dome light or anything, but okay, so no power so far, but that could be burned out for all we know. Yep, I'm getting nothing. No dice. So on to troubleshooting, I guess. Got to find out what the next step is here. Alrighty, so it looks like I found our culprit. It's actually the fuse from the DC to DC converter blew. So unfortunately, I don't have any glass fuses like this here. So this is probably just going to have to wait until tomorrow. But I'll probably try and run by the hardware store first thing in the morning and see if they have any glass fuses like this. This is just a standard glass 250 volt rated fuse. This is the fuse is rated at 7.5 amps. The DC to DC converter says it should be fused at 8 amps. So maybe between that and our big inrush current, reconnecting this after it had been disconnected for a really long time caused this thing to blow. What I might end up doing is before we connect the service disconnect next time is I might try and do another pre-charge cycle to avoid blowing the fuse. But I'll go ahead and get that back in there. Just like so. And we'll come back to this in the morning and hopefully we'll be successful then. Alrighty, it's the next morning here. I went to the store and got some glass fuses. Apparently my store also does not carry an 8 amp glass fuse, so I ended up with just another 7.5 amp fuse like what was in here. So yeah, you can see a little bit better now that we're in the light that thing blew. So we'll just pull that out. We'll stick our new one in. We'll go ahead and get that installed in here. And then to connect this, I'm going to use my pre-charge resistor here and just connect it to both sides of our service loop here to try and do a pre-charge and not risk blowing our fuse again. Limit any kind of inrush current, and then I'll quickly go and reconnect this. Now let's see if we have any signs of life. All right, so hopping in the car here. Still not seeing any lights or anything. Yeah, I still got no dome light. And I'm sitting on the key. Let's go key in. Okay. So still nothing. Well, I guess that the next step that we can try to do is maybe I can try and jump the 12-volt system. Perhaps the DC to DC converter simply is not working. Let's see, we'll try and disconnect this again. And let's see if our fuse held up this time. Yep, fuse is fine. There's no problems there. So, where could our issue be? I mean, it could be that this thing is toast. I guess what I'll do first is I'll probably check for pack voltage at our main DC connector there. And then I suppose I can do the same on the DC to DC converter here. And make sure that it actually has power. Yeah, interesting. We do, of course, have our other fuse box down here, but that shouldn't affect anything else that we have going on here. Well, actually it could, because there is a separate fuse for the DC to DC right here. Oh, well, there you go. That one is also blown. So that's fun. This one is a 6 amp fuse, which again, I don't know. I don't think the set of fuses that I bought came with a 6 amp. So back to the drawing board, I guess. Oh, they actually did have a 7.5 amp fuse there. Interesting. Well, I think that set of fuses that I bought only came with one 7.5 amp fuse. It says on here that it should be a 6 amp fuse. So that's interesting. Don't know why they would have 6 amp there and 8 amp here. Clearly someone put two 7.5 amp fuses in the system. Well, shoot, I might have to run back to the store and get another fuse. So I guess we'll come back to this. All right, take 3 here. Let's see if this time we can get this thing to start. We'll get another fuse in here. I was wondering why I didn't see any kind of spark when we tried to do our pre-charge. So now we'll try our pre-charge again. Okay, I think I heard a little bit of a spark there. I didn't see one, but... Ooh. That's interesting. Okay, I saw a little bit of a spark when I connected that. I guess we'll see if it starts now. All right, so it looks like we're mission failed yet again. The fuse in the DC to DC did blow, and I'm guessing the one in our fuse box over here probably also blew. Yep, so perhaps our DC to DC converter has a short in it. So I think what I'm going to attempt to do is we'll try to just bypass the DC to DC converter and provide our own power input to the car through this Anderson connector. I think that I have an Anderson connector that might fit, or there might be one in the trunk from their sort of put together charger setup that they had in the rear. So let me see if I can put something together and we can rig this up to provide external 12 volts to the car. All right, so I did successfully grab our spare connector from the rear that was in the charger circuit. Looks like we do have the correct polarity here. And then I've just got my power supply here. I don't know what the actual 12 volt output is on that, but I am going to turn this down on the voltage just a bit. We'll go to like 12.5. I'll shut that down. We'll connect our leads here. We'll try and turn our power up. Don't want to short there. Now let's see what happens if we try. Look at that, we're getting beeping noises. And I do have key in ignition. Let's see what happens. I hear vacuum pump. Well, how about that? Okay, we've got our seatbelt and our brake lights there. I don't know if I mentioned it before, but I think I realized why they covered the amp gauge up with this voltmeter. The control box for it is actually missing, so our amp hour gauge doesn't actually function. It looks like that might not be functioning either. But let's go ahead and take the brake off. Let's see what happens if we go into reverse. Okay, I don't have any movement. If I try and go into drive, do we get any movement? Nope, no movement in drive. Well, shoot, what else can we do here? Ooh, that's fascinating. So I'm trying to turn on our vents here. So our fan switch clearly isn't very happy there. If I put that on, will our AC compressor run? The AC light is on. I can't see if our compressor is running. The fan was running, but I don't think the compressor itself was running. Okay, well, we might have some other stuff to try and look at here. And I don't like that we're not getting a voltage reading there, so we might have to check our main... Well, our main high voltage connector should have power because we were able to... It was blowing the fuses for the DC to DC converter, so I'm going to keep playing around with this and see what I can come up with. All right, so I think I might have a good idea of what is going on here. I think that our selector switch is not wired correctly. So I know that this has been replaced because the original one was in a box in the back, and I swapped over the original handle to this. But I think that whoever installed this didn't wire it up properly. And there's one main reason that I know that that's true, because if I put this into the max range mode, you can see we get our reverse light coming on. So we've definitely got some screwed up wiring here. I've tried shifting it around to all the different positions. The wiring diagrams for this car are not great. There's no wiring diagrams really for the shifter at all, so I don't know really what wires should go where or what circuits need to be closed for each of the different selector positions. There are resistors for a bunch of the different positions. I do know that the neutral interlock is this connector here, which has purple and yellow there, and then two purples here. That one is closed circuit when the selector switch is moved all the way to max power. So yeah, there's definitely some screwball stuff going on here. I might have to try and look up the wiring diagram for the motor controller itself, which is an AMC 325, and see if I can figure out what the resistance values and all need to be. The problem is that I don't know where the pinouts are from here to the controller. So I suppose that when they wired this up, they probably matched the terminal locations with the original wiring and then put all the resistors back into place. But perhaps this switch, the terminations just weren't in the correct positions. So anyway, it's probably going to take me a little bit of finagling to figure out how the heck this is supposed to go. I don't really have time to continue messing with this today, so this is going to have to go back on the back burner until I've got some more spare time, and maybe I'll try and see if I can find some additional resources to get some more info on this. Oh, there goes the vacuum pump. But anyway, right now, I think that that's the main thing that's holding us up from being able to drive this, is just that it just doesn't have the correct wiring set up on here. I've tried putting it in all the different positions and depressing the accelerator pedal, but nothing does seem to do anything. So yeah, anyway, I'll just have to keep playing with this, see what more info I can figure out here, and hopefully I can get this thing sorted enough where we can get this to move under its own power. So I just came to a realization here. I forgot that I have the controller test box here. So what I might be able to do is actually just unplug the connector on the controller, plug this thing in, and see if we can get this thing to move, spin forward and reverse. That'll rule out our controller or anything being an issue. And like I said, I do suspect that it is that selector switch. What I'm going to do is I'm going to go ahead and get the car jacked up. I don't have a lift spot available right now, so I'm just going to jack the wheels up so that we can just free spin in the air. I'll get some jack stands under it. We'll plug this thing in and give it a shot. Alright, so we've got the car jacked up on the ground. I've got the test box hooked up. Let's see what happens when we hit on. Okay, I don't have anything lighting up here, so maybe not a great sign. Let's go forward. Yep, still got nothing here. Let me try and turn the key switch in the car on. I don't know if that'll do anything for us, but I don't think that that should matter for this. Yep, I've still got nothing here. Well, I guess on to the next thing. Okay, folks, we're back. It's been way longer than I wanted. It took much longer to get these fuses than I originally anticipated. At first, I ordered the wrong amperage rating by accident. So then I ordered the correct ones, and the shipment got delayed over and over again. But as you can see, I got a whole bag full of them. And I've installed one of them back in the controller here where it belongs. So I think our fuse holders there are pretty nice and snug. We shouldn't have any issues there. So I'm about ready to hook this thing up back to the Leaf battery that I was testing it with previously. Obviously this is very sketchy. Don't try this at home. But yeah, so I've got my cables hooked up that I'll be able to connect to the battery. So I've got one here that goes to the positive side of the rear stack, and then I've got another one, a longer one, to go to the negative side of the rear stack. This is pretty much at the upper voltage limit of what the controller is rated for here. The controller is nameplate rated for 190 volts. I'm sure it could go up to 200 or probably slightly over 200, but anyway, it's rated for 190. Our stack here is at 189, so it is below the nameplate rating. I've actually got the motor strapped to the table here. I don't think it's going to move because we're not attached to anything. It's not going to have any real torque on it, but I just don't want it to spin on us, if this thing does power up. So I just have it strapped down to the table so it doesn't move. And then, of course, I've got the encoder wiring from the motor hooked up directly to the controller here. And I've actually basically just bypass the intermediate harness that would be on the enclosure for the controller. So we've just got that bypassed for the moment. And then I've got my controller test box here that we'll be able to use to try and power this thing up. So I'm going to attempt to connect our cables, and then we'll see if we can power this thing up and find out if we get any signs of life at all. All right, you probably can't really see it because it's a little bit off screen on the camera there, but I've got the cables connected, and I can show you that we do indeed actually have power at the controller here. And it appears that our fuse is holding up, so it didn't blow immediately when I connected power. But yeah, there you go. We got about 189 volts. If we switch this to ohms, we can check and make sure our fuse is intact. Actually, I'll just put that on noise so I can hear it. Okay, so that works. Okay, that fuse is good. And our other two fuses are good. Let's see what happens when we switch this thing on. Okay, I'm not seeing anything yet. I don't see any LEDs that have lit up or anything. So still got nothing. Try and turn this knob and see if we get any movement. Nope, I got nothing. Okay. Try reverse. Still nothing. Okay, so I'm getting no signs of life here once again. So there's LEDs on the drivers and stuff in this thing. So did we blow a fuse again? If so, that's probably indicative that we have some sort of a problem. In which case, might require some further testing or something else. Nope, that one is still intact, as are those ones. And I guess I don't know for certain that my test box actually works. But I suppose the only other thing I could do is try and get this in the car and power it up in the car and see if that makes a difference. But yeah, I'm getting nothing here. Or if I can try and get a laptop set up with the program for this thing, I can try and connect it and see if we get any other signs of life that way. But as of this moment, things are not looking so hot for this. I don't see anything that looks physically damaged or blown. We've got our three phases all hooked up. But yeah, we just get no signs of life. I get no LEDs on the controller box. I get no LEDs in the controller itself. The contactor on here doesn't close. So yeah, this is unfortunately a bit of a bummer. Well, I guess I'll try to continue to experiment with this whenever I have some free time. And I might have some resources I can reach out to see if maybe somebody else who's a bit more well-versed on these might be able to assist with repairs or whatever. So anyway, I'll come back to you guys whenever I have some sort of an update, which most likely will be a long time from now, but who knows. Okay, folks, it's actually the next day as you're viewing this. I actually took this section of the controller out that has these three different boards on it. I did some investigation. I couldn't really find anything in particular that was a big problem point. I basically just disconnected everything. I tried to test some of the components on this board. It's kind of hard to test components on a board when they're in circuit, so I just kind of tried to test what I could. Everything seemed to check out fine. The capacitors, the big MOSFET that's under here. So I ended up just putting it all back together. And after I did that, one of the things that I realized is that I had this little safety disconnect loop not really connected before. I tried to sort of bypass it, but I don't think I had a real solid connection to it. So I ended up just taking the two wires off the brake switch that go onto this connector, and I just put the actual connector into place that has that little loop in it. and I decided to try and power it up, and lo and behold, it powered up. So as you can see, we get status lights here, and the thing actually powers on. The contactor closed. I don't know if you heard it, but there was a pretty good clunk there when the contactor closes. And then from that point, I didn't get anything else going on. It didn't show any other signs of life. So I tried, unplugging some of the different connectors just to see if anything would change. Nothing changed. So I plugged everything back in, and then just kind of one last time, what I decided to do is I took the cover off the motor just to make sure the phase wiring is correct, but nothing's really labeled in there, so it's kind of hard to tell what's going on. But I did realize something. I don't think this motor is wired the same way that the one in my Force is, and I think that the switch here is configured wrong for this motor. So if I flip it to the A position, which I already did this off camera, but if we do that, we put it into forward, and we give it a little bit of throttle. Look at that, we get some movement out of it. And I can spin it up. Now it's just kind of at idle. So the motor's just spinning just from its own inertia. If we move this back to regen, we can get the motor to regen to a stop. We can accelerate it again. We can go real slow. We can speed it up. And we can regen back to a stop. And of course, I can put it into reverse, do the same thing in the other direction. And regen it to a stop. And it seems like we're working. So I'm not really sure that I can totally explain what it is that I fixed. I don't know if we just had some poor connections on some of the connectors in here, or really what the heck was going on, but it appears to be working now. So I think what I'm going to try and do is I'm going to try and get all of this apart, reassemble the inverter the way that it's supposed to be with the cover and everything on it, and try and get it mounted back in the car. And then I'll have to see if I can figure out just a test battery setup that we can get into the car just to see if we can actually physically drive it. Whether that means I take the rear stack out of this and try and put it in the trunk, although I'm not so sure that it'll fit in the trunk of the Solectria very easily. So anyway, I'll try and come up with something, some sort of test battery to get it going. But yeah, I mean, it does indeed look like we've got a working controller now. So how cool is that? Anyway, yeah, I'm going to go ahead and power this thing off. We'll try and see what I can figure out, and we'll hopefully make some more forward progress, and hopefully by the end of this video, I can maybe have the controller in the Solectria driving, and then we can kind of figure out what we want to do from there. It's a new day. I've got the inverter all put back together and reinstalled into the car. I've got everything hooked up, minus our service disconnect. I also had a little bit of a theory on why we might have been blowing fuses on the DC to DC. It just had regular glass fuses that are just a fast blow fuse. I swapped out the fuses with a time delay or a slow blow fuse. So that's actually what the service manual for this car calls for basically all this stuff. So potentially it may have been an inrush current issue blowing those fuses. So hopefully the time delay fuse won't blow. If it does, I can always do what I was doing before and just hook up a jump pack to our 12 volt output there in order to power the car on. If you'll recall, this car does not have its own 12 volt battery. It just relies on the DC to DC converter. Since my test batteries died from leaving them connected in the car, I got them pulled out. And what I'm going to do is I'm actually just going to take the rear stack out of that leaf battery we were using just the other day to test the inverter. And I'm just going to try and shove that thing into the trunk here. I'll get it hooked up, and then we'll try and see if we can attempt to test drive the car, and hopefully we get some movement out of it, and then we can come up with our plans to actually build a proper battery setup for this thing. Okay, that was a little bit more of a challenge than I anticipated, but I got the rear stack from the leaf pack in here. I had to extend this cable a little bit. We've got our fuse in our junction there. This end is going to be the negative cable, so it's going to attach right there. Our positive cable is right here, and that'll connect right there. So I'm going to go ahead and get this stuff hooked up, and hopefully this will run. All right, our terminals are hooked up, both positive and negative. Let's go ahead and try to connect our service loop and see if we get any signs of life. It might still blow the fuse in the DC to DC converter, but you never know. I'm probably gonna have to do 2 hands for this. So let me set the phone down and get this connected. All right, I got that connected, but we got no signs of life, no dome light, no nothing. So I'm gonna say our DC to DC converter is probably still shorting out the fuse, so I'll go ahead and get a jump pack hooked up to our 12-volt supply there and see what happens then. Okay, jump pack is sketchily hooked up. Let's go ahead and power it on. We get beeping from the car. Like to see it. We got a dome light. Let's go on. Okay. So we've got a few different lights on. Oh, of course, that's our parking brake thing. Let's try and see what happens if we try and put it into any gear. Get nothing there. Nothing there. Okay, we're getting no signs of movement here. So I do hear a noise if I put it into max range. It sounds like it's trying to do something there. Well, let me continue to play around. I know that our gear selector is not working correctly, so it might just be a matter of trying to start it up in the correct gear, potentially. Okay, well, I'll continue to play around and see if we get any signs of life. All right, so back to the drawing board here. I've got the test box hooked up. I've tried a couple different things, and so far I've made no progress. So I'm not sure if maybe there's a problem on the motor side here, or possibly the encoder on the motor. But if we try and switch it on and put it into either forward or reverse and give it some throttle, you can hear it making some noises, and it'll start to kind of shudder back and forth really bad. I've tried the selector switch inside the motor. The A and B switch does the same thing both ways. So I think what I'm going to do is I'm going to try and grab the motor that we were testing with over there earlier off the table, and I'm just going to hook it up to the controller and, I don't know, set it under the hood here and see if it works if we hook that other motor back up. And I guess then we can rule out the controller as being an issue and something with the motor end of things. So I'm gonna go ahead and get that in here and we'll give it a shot. All right, got the test motor back under the hood here. I've got everything hooked up. Let's give it a shot. So we'll go on, try forward. Okay, and we do have movement, so we must have a problem with the motor. because it seems to be working with this motor attached. So I guess that gives us a couple of different options. I can either swap the motor in the car out with this one just as a complete unit, or I could try to open up the encoder side, which is on the back here, there's a cover plate for it, and see if maybe we've got a problem there. I would doubt that there's a problem with the windings in the motor. My guess is that it's probably more of an encoder fault than anything. But, well, either way, it's a lot of disassembly to get in there and figure it out. So, yeah, I guess I'll have to come up with a game plan. It's pretty much the end of the day here, so I'm probably not going to mess with this thing anymore today, as per usual. Maybe I'll come in and try to work on it tomorrow. It's actually the weekend, so I've got other stuff I need to get done. And I've actually got family coming into town tomorrow as well. So this might have to wait another week before I get back to it. But I'm going to make sure to disconnect the test batteries this time while the car sits. Don't want to make that mistake again. Yeah, bummer. I thought for sure we were onto something, but I suppose if we want to swap just the motor out, it's probably not that big of a deal. It's just real tight access in here to get it out is the real problem. Oh, and this motor has a different faceplate on it, although that can be swapped out. The end plate from here forward is actually different between these two motors, so maybe I'll try and look at the encoder issue and see if maybe that's it. I do know that both motors are the same model. They're both an AC GTX 20. I'm pretty sure they've got all the same info. Yep, they're both 12 kilowatt continuous, 85 amps, 7,400 RPM, 250 hertz. Yeah, so they're both the same motor, just with a different end plate on them. So, all right, like I said, back to the drawing board, I guess. But, yeah, I guess I'll come back to you guys when I actually come up with my game plan for this thing. I guess one more thing before we go home for tonight, I want to make sure that all the control side stuff in the car is working. So rather than using the test box to spin our test motor, I'm going to hook up the jumper pack. We'll try and turn the car on and make sure that our throttle, pedal, and gear selector and all seem to work. There's our key. So let's go on. Okay. Okay, so we must actually be in neutral. Maybe. Okay. So I know that it won't, I don't think it'll work unless you start it in neutral. I'm pretty sure that this is where neutral is, the max power setting. So I guess I made that mistake before. Well, how about that? So we are getting movement. I can hear it. I don't know if you guys can see it on camera or not. But you might be able to hear it. So our throttle and regen are working properly. It's just our gear selector positions are off. So anyway, that's that fun. Yeah. I guess that next step is to try and figure out what we're going to do with the motor. But again, like I said, not going to do that today. It'll probably be next week or something. So I guess I'll see you guys when I see ya. All right, I lied. I'm still here working on this thing. I couldn't let this go. I decided to pull the cooling fan off and the cover plate on the back of the motor here. And now we can see our encoder. So if we go ahead and turn our test box on, I've got the car just up on jack stands here so it doesn't run me over, but we're just in neutral. If I go ahead and spin the tire with my foot here, you'll see these little LEDs on the encoder board light up. It actually shows up a bit different on camera than what I'm seeing in person, but the lights are definitely kind of alternating, and one is quite a bit dimmer than the other. So we might have an alignment issue, or maybe the sensors on the back side are dirty. I also noticed something else. If I get my light in here, those two black wires that you see hanging down, those are supposed to be for the motor speed sensor, and they are not attached. They're just floating around in here doing nothing. So they're supposed to be attached to those two little posts right there on the bottom. Focus. right there, just below the white plug. And the ground shield is also not attached on here the way that it should be. It should have a little ring terminal on it to attach it. So I'm thinking maybe somebody's had this encoder board out before, and maybe there actually is a problem with it. I guess what I'm probably going to try and do is maybe pull it out and see if I can clean it, and probably see if I can get a ring terminal on the end of the ground shield here that's supposed to attach inside. Of course, that's... Oh, wait a minute. No, it is grounded. But it's grounded to a different spot. Okay, well, that's a little bit different than what I expected. It's different than my other one. So the other one here has a ground back here. I wonder if maybe it just has a poor ground, because there is a spot to put the ring terminal on the other one. I mean, I guess if nothing else, we could swap this board to the other motor, but I'd have to cut the wires off and resolder them. I mean, I guess I have to solder them on the other board anyways. But I'd like to try and see if we can get the other board working first. So I might try and pull that one out, see if it's dirty or whatever, and then I guess we'll go from there. All right, so I got the board out. I did notice as I was taking it apart, though, that it looks like we were missing a spacer washer that's supposed to go under the hole here on the outer edge, and then under the hole sort of in the middle, there's a spring. So we got the spring, and we got both the fasteners out, but it looks like we were missing the spacer. So there may have been an alignment problem going on here. I mean, the LEDs were blinking, but one was definitely quite a bit dimmer than the other. So potentially maybe that's what we had going on. I can see on the one over here, of course this is from an earlier motor, but if I can get the camera to focus, you can see there's a plastic spacer washer under the board there. So it's making me wonder if we've got a problem there. That, and there is a spot for that ground to go back here. With the board out of the way, you can see it. There's that little plastic doohickey around it. So it definitely looks like somebody's had this thing out of here at some point. So I kind of wonder if maybe it just got assembled improperly. Obviously, we're missing our motor temperature sensors. I don't know if that'll cause a fault with this thing or not, where it won't spin. It might, if it sees that it's open circuit. I don't think that it would try to deliver power at all, but I suppose that's another thing that we can look into. Obviously, I can just resolder the wires back to the board, but I don't know that I want to go to the effort of soldering it back together if we're just going to have to pull it back off again and swap it with that other one. So maybe I'll try and see if I can find a resistor just to fool the existing temperature sensor wires and get this thing reassembled in there and see if that makes any difference. I guess we'll find out. All right, so I got the board reattached, and as you can see, I've got a little group of resistors just kind of stuck on there. They're just sort of coiled around the little terminations on the board. I did measure it with a multimeter, and it looks like it's measuring the correct measurement, which should be about 325,000 ohms, at least based on my measurement with the other motor. Let's go ahead and power this thing up with the test box and see if we get any difference. I did try and align it. The edge of the board should be about 1/8 of an inch from the wheel. So I guess we'll see if that made any difference. And it's looking like that's going to be a negative. All right, so it looks like we've got no difference. I'm also noticing that when I put it into regen, I don't know if you can hear that on camera with my mic, but it's definitely like trying to regen even though the motor's not spinning. So I think that makes it pretty clear that I think that we have a problem with that board. So I guess what I might try and do here is swap out the board with the other one, and I guess we'll see if that makes a difference. All right, let's see if it works this time. I got the encoder board from the other motor swapped onto here, and once again I've just got the resistors on there for the temperature measurement. Let's try and power it on. See if we get any movement. Oh, it might help if I actually had it plugged in. Let me turn it off, plug it in. Whoa. All right, now let's give it a shot. On, forward, I got nothing. Why do I have nothing? Well, now I've got zero movement at all. So what's going on? Okay, so it's still not quite right, but it's doing better than it did before. All right, apparently I need to move the tripod to a spot where I don't keep hitting it. Just don't know if you guys will be able to see from over here. Well, anyway, I'm going to go ahead and try and adjust that board a little bit and see if I can improve things. All right, I've had some success. So what I didn't realize is that this motor and the other motor that I have are actually wired differently. So one is Delta and one is Y configuration. I don't know why they're set up differently, but we have to flip the switch in the controller here in order for it to be able to rotate properly. So now, if I turn it on and I put it into reverse, you can see we get some nice, smooth acceleration. And then we can regen to a stop. Now in forward, it does behave a little bit weird. It's a little bit jerky at the beginning. So right there, it's doing kind of this weird, like, cogging thing. And if I get past a certain point, then it spins up all of a sudden. So I don't know if that's just because we don't have enough load on it or what. Maybe it's got a different throttle profile for forward versus reverse. I guess I could try and turn this power saver knob and see if that makes a difference. Well, it seems to act more or less the same. But yeah, I guess that at this point I could try to test drive this. I probably am going to wait until tomorrow morning because as you can see, it is dark out, and I probably don't want to go driving this around in the dark and get stranded on the street somewhere. So I am going to come back to this in the morning and we'll try and take it for a test drive. Okay, it's the next day here. I've got the car at least as buttoned up as we need to for a test drive. I got the cover back on the back side of the motor for the encoder there. I didn't bother putting the cooling fan on because we're not going far and it's pretty cool out today anyways. I can't fit my jump pack under the hood with the hood closed on this. So I just kind of rigged up a 4S leaf module. This is from a 40 kilowatt hour leaf pack. So that's going to be our low voltage power supply since our DC to DC converter's dead. I've got the high voltage pack already hooked up in the back of the car. So I'm going to go ahead and hook this up, and then we'll try and take this out on the road and see how it goes. All right, hopping in the car here, we can hear it beeping, so we know we've got power. And again, our selector switch there is incorrect, so max power is neutral. Let's go ahead and turn it on. Okay. And let's try and go into reverse, which if I remember right, was going to be max range. And the throttle pedal on this is super weird because the top half of the throttle is just for regen, and then the bottom half is for acceleration. So you have to press the throttle like halfway down just to even get to where it starts to deliver power. And look at that, we're moving backwards. So let me go ahead and get pulled out of the shop here, and I'll come back to you guys as we're getting back out onto the street. All right, we're getting out onto the street here. I don't know if our drive mode is max range, normal, or max power. So I guess we'll just get whatever we can for drive. But look at that, we are moving under our own power here. And if I let off, it does regen. Although it does behave a little odd there. It's definitely pretty jerky, so we probably still have some other issues, maybe with, who knows, settings, encoder issues, but we are indeed moving. And it does actually move. It's not fast by any means, but if I push the throttle all the way down, it does accelerate. Guess I should make sure that we actually have decent brakes. So I'm going to turn regen off by going into slippery here. Okay, our brakes do work. I'll go ahead and turn regen back on. Well, dang, how cool is this? We're actually moving around under our own power with this thing. I'm going to take it out onto a bigger street where we can get it up to speed a little bit more. I'd like to see what happens if we get it over, 25, 35, something like that. I probably don't want to take it on any too major a road in case we get stranded. But it looks like we are moving along. All right, we're going to make a right here onto this bigger road where we can get up to speed. See what it does. So that's full throttle. Okay, and it is unhappy about going more than about 30 miles an hour here. Yeah, it's jerking pretty heavily. So don't know if that's an encoder problem or something else going on. If I let off and regen, it does regen pretty decent. We're going to make another right here and head back to the shop. If I do let off the throttle and just let it regen, it will come almost to a full stop. Well, I mean, it basically does come to a full stop on its own, which is kind of cool given that it's just an induction motor. There's no permanent magnets in these. So it does basically regen to a stop. That's kind of neat, but clearly we've still got some bugs to work out. Yeah. Our voltmeter there is pegged because we're actually above 175 volts. We're probably around 180, 185 would be my guess on our battery back here. But yeah, I guess we've at least got a successful test drive. But clearly we still have some issues. Alrighty, folks. Well, I think that's going to do it for this video. Clearly we got the car back on the road and moving under its own power, but we definitely have some bugs to work out. Anything above like 30 or 35 miles an hour, it gets really jerky and it just won't accelerate past that. So maybe I just need to adjust the encoder a little bit better, or perhaps we've got something else going on. Of course, our DC to DC isn't working, so we either need to repair or replace that. And last, but certainly not least, is we need to figure out a permanent battery situation with a BMS, a charger, all that good stuff. So hopefully you guys will be seeing that sometime in the not too distant future. So make sure to stay tuned. I can't promise that I'll have anything out too soon on this because this is a back burner project for me, of course. Most of the time I'm working on customers' cars, but I'll get to it when I get to it. And hopefully you guys will be able to see that sometime in the future here on Out of Spec Renew. So, as always, thanks for watching.